All right, today we're going to be introducing a new concept. It's called slope. So our lesson is called Meet Slope. We're doing lesson 210, and slope is just the steepness of any straight line. So let's write down that definition. So when we're looking at slope, we're determining how fast the line is increasing or decreasing on a grid. All right, we're going to start with lesson or activity 2. It says the figure shows 3 right triangles, each with its longest side on the same line. Your teacher will assign you 2 triangles. Explain why the 2 triangles are similar. We're going to actually just compare all 3 triangles. So I'm going to highlight them in different colors. And as I'm doing that, I want us to think about what we know about similar triangles. Some things we should know is that similar triangles have the same angles. Okay, if we look at those triangles, they all have the same angles. They also need to have the same scale factor in each side length. So if I go from triangle ABC, a side length of 3, to a side length of 6, I have a scale factor of 2, sorry. Because 3 times 2 is 6. If I'm going from triangle FGH, where I have one side length of 2, to ABC, where I have one side length of 4, I can see I have a scale factor of 2 as well. Okay, so we know that they have those same angles and similar scale factors. All right. It says to complete the table. We're going to look at the length of each vertical side and length of each horizontal side, and then we're going to divide vertical by horizontal. So if we start with ABC, our vertical side length is 3. Our horizontal side length is 4. So our fraction would be 3 over 4. If we look at CDE, our larger triangle, it tells us our vertical length is 6, but then we have to count 1, 2, 3, 4, 5, 6, 7, 8 is our horizontal side, and 6 over 8 simplifies to 3 over 4. Our last one, we don't have our vertical length, so we'll have to count that. So we have 1.5. And then our horizontal length, they told us, was 2. And 1.5 over 2 actually becomes 3 over 4 as well. And if we want to double check that all of these things are the same, we can do those problems as division. So 3 divided by 4 is 0.75. 6 divided by 8 is 0.75. And 1.5 divided by 2 is also 0.75. These values, when we do our vertical, make sure you're writing down what I write down, divided by our horizontal, is how we find slope of a line. Okay, so anytime you know your vertical side length and your horizontal side length, that's how you're finding slope. So whenever we are given a straight line, we can create triangles, right triangles, and find our vertical and our horizontal side lengths. This is also called rise over run, and that also will give you your slope. Maybe take a minute to pause your video and make sure you have everything written down on this page. When you're ready, resume the video and turn to the next page. Activity 10.3 says, draw 2 lines with a slope of 3 what do you notice about the two lines? So first of all, we know our slope is 3. But we also know that slope is rise over run, or vertical over horizontal. So if we have a slope of 3, in order to make that into a fraction, we would need to think to ourselves, what can I divide 3 by that won't change what 3 is? And that answer is 1. So 3 is equivalent to the fraction 3 over 1. So our first step is to choose any point on the grid. I'm going to just go right here. From that point, we need to have a rise of 3. So I'm going to go up 1, 2, 3, and a run of 1, putting my new point on this grid. I'm going to do that twice. 1, 2, 3, over 1. Now I have 3 lines. I can draw a straight line through them. Okay, so my blue line has a slope of 3. And you can check that by making those right triangles we saw on the first page. So if I connect my 3 and my 1, I have similar right triangles. These two happen to be congruent. All right, now I'm going to choose this point here because it said to do 2 lines. I'm going to have a rise of 3 again, a run of 1, and put my new point. Rise of 3, run of 1, rise of 3, run of 1, we're going to talk about what we notice after we draw our next 2 lines. So our next 2 lines want to have a slope of 1/2. So that means my rise over my run. My rise is 1, my run is 2. All right, so let's go here. My rise is 1, my run is 2. My rise is 1, my run is 2. You can actually repeat that as many times as you want. I'm just going to draw my line through those 3 dots. Okay, and we're going to do one more. I'll start here. Rise of 1, run of 2, rise of 1, run of 2, and like I said, we can do it as many times as we can. And here we have our second line that has a slope of 1/2. So it wants us to look at these lines and figure out what we notice. We should be able to notice that when lines have the same slope, they will be parallel. So anytime you have lines that have the same slope, they'll be parallel, just like our lines that have a slope of 3 are parallel and our lines with a slope of 1/2 are parallel. Once you've caught up and have everything written down here, let's move to the next page. Activity 10.4 says different slopes of different lines. Here are several lines. Match each line shown with the slope from the list. So let's just go ahead and start by finding the slope of each line. So I'm just going to write the word slope here. And then I'm going to use the triangle they provided to identify the slope. This is something critical that they don't mention. They just kind of assume we would know. Anytime you're identifying a slope triangle, your points, I'm going to zoom in so you can see what I mean, have to be at a 4-way intersection and can't just be a random point like right here. That wouldn't work because we don't really know what that point is. So when we're using a line to identify slope, we have to use, I'll show you all of the available points on this line, points that line up at a four-way intersection of grid points. So we can truly identify what that coordinate would be. So the line they provided us is here, or the triangle, and we have to find rise over run. So my rise is 3, my run is 2, so my slope is 3 over 2. And then we can look and see, was that an option in my list? Yes, so I'm going to cross it out. All right, let's try B. Maybe pause the video and try B on your own. For B, we have all of these options, but the ones they chose are here. So for B, we have a rise of 2 and a run of 5. Nope, sorry, 6. Making our slope 2 over 6 or 1 over 3. When we look at our list, 2 over 6 isn't listed, but 1/3 is. So we know we found one of the slopes. All right, looking at C next. Go ahead and pause the video and try to find the slope of C on your own. C has a rise of 5 and a run of 5, which gives us a slope of 5 over 5. 5 divided by 5 is 1. So our slope is 1. And that was an option. All right, when we look at D, now we don't have a slope triangle provided for us, so we're going to have to draw one. Go ahead and try to determine what points are viable options. I'm going to show you. These are our options. And then I'm going to show you that you can do different slope triangles and still end up with the same value. So let's say I chose these two. I'm going to get a slope of 4 over 2. But what if I chose these two? Oops. Now I have a slope of 1, 2, 3, 4, 5, 6 over 3. And what if I chose these two? Then I would have a slope of 2 over 1. If we compare all of these fractions, 4 over 2, 6 over 3, 2 over 1, they would all simplify to the same value, which is 2. Okay, so it doesn't matter what points you choose, as long as you choose points that are on the grid lines perfectly. Try E on your own. E has a rise of 1 and a slope or a run of 4. I don't see that in my list, but I know it's not 1/2. So to figure out if it is equal to that 0.12 or 0.25, just divide 1 by 4 And it is that 0.25. So slope can be written as a fraction, as a whole number, or as a decimal. All right, notice we didn't use our 1/2. It says to draw a line for this on empty grid F. Okay, fun part about knowing a slope and getting to draw our own line is we get to choose a point anywhere on the grid and use that. So my slope, we said, is 1/2. So my rise is 1 and my run is 2. Giving me a line that looks like this. When you're finished with this page and you're understanding what I'm saying, you can turn to the summary page on the next page. Here is a line drawn on a grid. This time there are 4 right triangles drawn. If we look at these triangles, they're all similar triangles. They're all examples of slope triangles where one side of the slope triangle is on the line, one side is vertical, and the other is horizontal. The slope of the line, so let's underline or highlight this, is the quotient of the length of the vertical side and the length of the horizontal side in one of the slope triangles. This number is the same for all slope triangles on this line. In this example, the slope of the line is 2/3, which is what all 4 triangles have in common. Here's how the slope would be calculated for each triangle. All right, let's define slope. Slope is the steepness of any line drawn on a grid. Or let's reword that. Any, just let's say straight line. Because sometimes we don't have a grid and we can still find the slope. Slope is found by doing vertical change over horizontal change or rise over run. All right, once you have that written down, move on to the practice. If you're unsure how to do any of the first 2 practice problems, there are examples of how to do this previously in the video. So rewatch the video if you need help determining how to identify slope or how to draw a line with a certain slope. Number 3, we should be able to do determining how we know that 2 triangles are similar. And you can skip number 4. All right.